Hey everybody, so let's go ahead and get started with our Unit 2 review. So to get started with this review, guys, we want to go ahead and go over our transformation rules, right? And so when we have an example like this, where we have x plus some h value, we are going to assume something like this, like y equals the absolute value of x plus 2. And we know that we'd go 2 units to the left. It's always the opposite, right? And so in that same style, when we have y equals the absolute value of x minus 3, then we would go 3 units to the right. Okay? For f of x plus k, if we had something like y equals the absolute value of x plus 4, well then we'd go 4 units up. If we have y equals the absolute value of x minus 5, well then we'd go 5 units down. When we're talking about dilations, like in the next part, where they're saying numbers that are greater than 1, so like 2, 3, 4, 5, 6, like y equals 4 absolute value of x, then we'd have a vertical stretch by 4. And in that same fashion, if we have some type of fraction, okay, or decimal that is between 0 and 1, like we'll do y equals 1 over 7 absolute value of x, then that would cause a vertical compression by 1/7. If we have some negative absolute value, something like y equals negative absolute value of x, that will cause a reflection. Okay, so just a little review of what we started at the beginning of this unit, and we've seen this and been using this ever since. So let's go ahead and do some real problems. This first problem says, for what value of k does the value of k, for what value of k does the value of k with the equation absolute value, so we're going to say absolute value of 3x minus 1 plus k equals 7, would this be no solution? So what does that mean, right? Like, how do we get no solution with absolute values? So we cannot, and this does not exist, and I'll show you this right now, we can never get the absolute value of a negative number. This cannot happen. We can never get the absolute value and get a negative number. Like, I can never say, what is x going to be to give me negative 2? Nothing. We can never get negative 2 because whatever the value is for x will always be positive. This can never happen. Absolute value of negative 100? No, this can never happen. The absolute value of negative 0.0001, even a super small number? No, this can never happen because we can never get the absolute value of a negative value. So let's try these out. Like if we got, and we're going to go ahead and test that first one. If we said 3x minus 1 plus, and we used 1 equals 7, well, I can subtract 1 from both sides, and I get the absolute value of 3x minus 1 equals 6. Well, I can solve this. That won't give me no solution. That can be done. So that is no good. Let's try another one. Let's do the absolute value of 3x minus 1 plus 5. Okay, let's try this. Plus 5, so I'll subtract 5 from both sides. So I get the absolute value of 3x minus 1 equals 6 minus 5 is 1. Well, I can do that. I can solve that. You guys know how to do that. So that will give me a solution. All right, let me try the next one. So if I do the absolute value of 3x minus 1 plus 8 equals 7, I'll subtract 8 from both sides. So I get the absolute value of 3x minus 1 equals 7 minus 8 is negative 1. Okay, there is no value that I can put in here, even a negative, because once I take the absolute value, it's going to make it positive. This is no good. Okay, this is no good. I cannot do this. I cannot do this because of this negative number. Okay, well, let's just double check. Let's do the last one. If we said the absolute value of 3x minus 1, okay, plus 7 equals 7. If I subtract 7 from both sides, okay, I get the absolute value of 3x minus 1 equals 0. 7 minus 7 is 0. Well, I can solve this. Okay, I can solve this because we can get 0. The absolute value of 0 is 0. Okay, so that means that our answer here has to be 8 because it's going to make that number on the right side after I isolate the absolute, it's going to make it negative. Okay, it's going to make it negative. All right, let's go ahead and go on to the next one. So this question, guys, this question was actually from one of our lessons. I feel it's important that we go over this, right? And so this one says the length of a standard basketball court can vary from 84 feet to 94 feet inclusive. Write an absolute value inequality that describes the possible lengths of a standard basketball court. So we're talking, and we're going from 84 to 94. Well, this is one of those questions where we want the central value and the range. Well, they didn't give us the central value or the range. They gave us the span of it. So remember, our central value is whatever number is in here in the middle. What's in the middle? Well, there's two ways of doing this. You can take the average. You can do 94 plus 84, divide that by 2, and you'll get 89. Or you could also do 94 minus 84, and you get 10. So the whole thing here is a distance of 10. So that means that this middle value is at a plus 5. So that means that my central value is at 89. 89, right? Well then, how far are we from 84 to 89? Well, that distance is 5. That is our range value. Okay? So we've identified our center and our range. It's just the center is the number in the middle, and our range is how far is that number in the middle to one of the two boundaries. Okay? Then to get this answer, we're going to use the equation, the absolute value of x minus c is less than or equal to r. We just plug in our values. So we're going to get the absolute value of x minus 89 is less than or equal to 5. And that's it. This is how you solve that. We just want the equation, actually the inequality. Okay? Let's go ahead and move on to the next one. All right, so this was actually a do now from a couple of weeks ago. And I just wanted you guys, because I really like this question, and we all did really well on this, but I want to go over this. So we're identifying which statements here are true, right? So statement 1 says the range is going from negative infinity to infinity. So range is how far up and down. Well, if I assume that these arrows are going on forever, well, I know we're going up forever, but we bottom out here at y equals 2. So my range is not all real numbers. It stops here at 2. Okay, now my domain, the domain we can say is all real numbers, or that negative infinity to infinity. But it's saying range, and because it's range, this statement is not true. Okay. For the y-intercept being at 0, 5, well, the y-intercept is where we cross the y-axis. Well, here we are, and we're at 0, 4. We're in between 4 and 6, so that would be 5. So this statement is true. Okay. And the next part is saying that the vertex is at 3, 2. Well, we're going to go 3. Here's 1, 2, 3. 1, 2. Here's my vertex at 3, 2. So this statement is also correct. So our answer choice would be 2 and 3. Very cool, very cool. Okay, just to refresh our memories on how to analyze these. So this one is saying what transformations is the absolute value function below. So if we saw this as f of x equals the absolute value of 1/4 okay, x plus 3 minus 2. This looks very similar to what we've been doing, and we follow the same rules. Okay, we'd follow the same rules. The only difference is this 1/4, the position is a little different. We're used to seeing it out here. But it means the same thing. It's just they multiplied it in. You're still going to treat it the same way. So we would have because of that, we'd have a vertical stretch by 1/4. This part in here, we have x plus 3, so we'd go 3 units left. Okay, remember we do the opposite, right? If it's a plus 3, we go to the left. Had it been minus 3, we would go to the right. And the last one here is we have that minus 2, so we're going 2 units down. Okay, so this is just a little bit of review. We've been doing this. I just want to make sure that we understand the notations and we understand how to solve these. Okay, let's do another one. So where is the equation for the graph above? Okay. So with these types of equations, guys, we want to look at our formula of absolute values in vertex form. Okay, and so we know that A is going to cause some type of vertical stretch or compression. We know that this x minus h is going to cause some shift to the right or the left. And we know that this plus k is going to give us some type of up or down. So let's do what we know how to do first, right? Let's go ahead and let's look at this, where our vertex is. Our vertex, we're going to say, is at 4, 0. Right? 1, 2, 3, 4, 4, 0. That's my x and my y. So with that, I know that I have y equals a, because we haven't looked at any vertical stretch or compression. Okay, absolute value of x. Now we want 4 units to the right, so we're going to go x minus 4. All right, 4 units to the right, so it'd be x minus 4. And then we don't go up at all. We stayed there, so it'd be a plus 0. And we can get rid of that in just a little bit. Okay, so we can go ahead and rewrite this as y equals a, absolute value of x minus 4. Okay, well, I still need to know that a value, right? I still need to know that guy. Well, our a value, we treat this like a slope. Okay, so that's the same thing as like a rise over a run. So when I do this, I want to look at my starting point, and I want to go ahead and start looking like, where else does it cross perfectly on a grid axis? Okay, so 1, 2, it looks like it crosses real nicely right here. Here it's kind of skips, it doesn't touch, but here to here it goes really good. So we're going to rise 1, 2, 3, 4 over a run of 1, 2, 3, 4, 5. Cool. So that's all that change was. That is all that change was there. So then our final equation would be y equals 4 over 5, absolute value of x minus 4. Okay? And then, like, if you're given scenarios of, like, what is the y value or whatnot, it's always just whatever values they give you. But if you're able to do this, you're going to be pretty set. Okay? Let's do one more problem together. Okay, so describe the following equation as a piecewise function. So piecewise functions, that was the very, very first thing we discussed in this entire unit. So we're going to kind of jog your memory about this a little bit. So if we said f of x, we know that this is going to be 2 pieces, right? So I went ahead and I provided a graph here. Absolute values are always going to give you 2 pieces. Always, okay? And so our first piece is going to be from here to here, right? Where our vertex is. This is going to be 1 piece. Your next piece goes from where your vertex is, and it goes on forever too, right? Because this line goes on forever. So it's split up here wherever it's being graphed at, right? Okay. So let's go ahead and work this out. And what I want you guys to see here is when I'm looking at the graph, I see this positive slope. And when I look at the other half, so right, we have a positive slope. I have some type of negative slope. Okay? So when we're working this out, well, we're going to want to go ahead and solve this. And what I mean with that is we want to kind of drop those absolute values and get an answer, right? So when we solve this, when we say f of x equals negative absolute value of 2x plus 2 plus 3, we're going to distribute that negative in here. So we're going to get negative 2x minus 2 plus 3. Okay, we'll combine like terms. So we're going to get f of x equals negative 2x. Negative 2 plus 3 is a plus 1. Okay, so this is one of our answers. Now, which answer is this? Well, to identify that, you want to look at the slope. We have a negative slope here. So this has to be this guy here. This is where he's going down. So we're going to write this down here. We're going to say negative 2x plus 1. And from where to where is he going? Well, he's starting here when x is negative 1. So we're going to say when x is greater than or equal to negative 1. Wow, that's a lot, right? Okay, well, you'll be fine, you'll be fine. Let's go ahead and do the other part. If we say f of x equals negative absolute value of 2x plus 2 plus 3, well, we kind of want to apply like that KISS method like we've done in the past, like we were doing yesterday, but we're just going to multiply the equation by a negative. So when that happens, when we multiply by a negative, this just becomes plus. Okay, this will become a plus here. So when we distribute it, well, nothing's going to happen. So we're going to get, this is going to be 2x plus 2 plus 3, combine like terms. So we're going to get f of x equals 2x plus 5. 2 plus 3 is 5. And you'll see here, okay, that I have a positive slope. So that's got to be this one. That worked out. You're always going to want to get one positive and one negative. Okay, so with that positive slope, I know that this is on the left side, so he's going to do the first one. We're going to say 2x plus 5. And this is for when all numbers, all values of x are less than negative 1. And I know this is like a huge throwback, like 3 weeks back, guys. But I want to make sure that we review this. Take the time to study this. And if you really understand, you should be good to go. Okay? Make sure that you guys study. Send me a message if you have any questions. And get some rest. We'll see you tomorrow, guys. Bye-bye.